Hey guys, I have spoken about magnets in my new video. This video consists of certain basic principles and concepts of magnetic world. Kindly watch this video and comment on the quality of the content. Welcome to Shapers Learning Academy. Happy learning. Magnetism. A magnet is a material or object that produces a magnetic field. Magnetism is a result of electromagnetic force, or called as EMF. It refers to the physical phenomena arising from the force caused by magnets. Magnets in real time have multiple advantages and uses in real cases. A common application of electromagnets or magnets is our electric motor. Magnets are one of the important constituents of electric motor. Magnetic field. A magnetic field is a vector field. When you try to understand this vector is a physical quantity which has both magnitude and direction. So in physics, if you are defining a quantity, and if the quantity would have both the direction as well as a magnitude, then that particular quantity is called as a vector quantity. So a magnetic field is a vector field in which the neighborhood of a magnet or electric current or changing electric field. So an area that is surrounding a magnet which experiences a magnetic pull is called as magnetic field. So the magnetic field is a vector quantity which has both magnitude and direction. Certain properties of magnetic fields. Magnetic fields never cross each other. So you can see the magnetic fields, the lines of magnetic force doesn't crisscross or never cross with each other. The density of the field lines indicates the strength of the field. The more the lines which are close to each other, it means that the magnetic field is denser over here. Magnetic field lines always make closed loops. So the loops start from a pole and ends with a pole. Starts from the north pole and ends with the south pole. Magnetic field lines always emerge or start from the north pole and terminate at the south pole. So it starts from the north pole and terminates at the south pole. Magnetic flux. Magnetic flux is a quantity. Magnetic flux is a measurement of the total magnetic field which passes through a given area. Just imagine this be an object which is subjected to magnetism. The amount of magnetic field or the magnetic lines of force which passes through this particular object is a quantity and is called as a magnetic flux. So magnetic flux is a measurement of the total magnetic field which passes through a given area. It is a useful tool to describe the effects of magnetic force on something occupying on a given area. Electromagnetism is an interesting concept to learn about. Electromagnetism is a branch of physics involved in the study of electromagnetic force, a type of physical interaction that occurs between electrically charged particles. Before getting deep into electromagnetism, so the name is a two-word syllable which says electricity and magnetism. Electricity and magnet. Electricity and magnetism both are interrelated with each other. There can be an electricity produced because of a magnet, or there can be a magnet produced because of electricity. A very common experimentation is as shown in the below figure. Here you have a cell which is a power source. Here you have a metal nail. So an electrode is being a metallic wire has been wound around this particular steel nail. Now when when electricity passes through these wires and through this coil, This metal becomes a magnet due to the passage of electricity, and hence it is called as an electromagnet. So this concept has been used in various other fields, various other components and various other machineries, and there are various applications where this particular concept has been implemented. The electromagnetic force is carried by electromagnetic fields composed of electric fields and magnetic lines. Electromagnetic induction. Induction is the concept of producing something. So electromagnetic or magnetic induction is the production of an electromotive force across an electrical conductor in a changing magnetic field. So here is a beautiful example of electromagnetic induction or electromagnetic force. The best example which I can give you in real time is a generator. A generator has magnets placed nearby each other and they constantly move. Because the magnetic lines of flux or the magnetic flux or the magnetic lines of force are cut across each other, a voltage gets generated, and that particular voltage is called as electromotive force. So the concept behind a generator, working of a generator, is electromagnetic induction. Electromotive force. The electromotive force is a force that exerts during the transfer of electrical energy between high electric potential and a low electric potential. Let us understand certain basic laws of electromagnetic induction. So we have two laws, Faraday's law 1 and Faraday's law 2, and the scientist Michael Faraday is the father of electromagnetic induction, and it's because of Mr. Michael Faraday we have all the generators as well as electric motors working across the world. See, Faraday's law of induction states that, or Faraday's law of induction is a basic law of electromagnetism predicting how a magnetic field will interact with an electrical circuit. So briefing once again, in a generator, magnets are placed nearby each other so that there is a magnetic field or magnetic lines of flux, magnetic flux is being produced, and the magnets are moved across each other in a constant speed, and hence there is a magnetic field is being cut down or it is being disturbed, and there is, because of the disturbance, a force or an voltage gets generated which is called as electromotive force or called as induced current. So the Faraday's law deals with the electromagnetism and predicting how a magnetic field will interact with an electrical field. So Faraday's law states that any change in the magnetic field of a coil of wire will cause an EMF to be induced in the coil. This EMF induced is called induced EMF, and the current induced is called induced current. So as I told, when there are magnets, when there is a change in the magnetic field, an EMF gets induced. That is what is called as Faraday's law 1. Faraday's law 2 states that the magnitude of EMF induced in the coil is equal to the rate of change of flux. So the magnitude is directly proportional to the rate of change of flux linkages with the coil. Thank you. I hope this video would have given you certain introductions about the magnetic world. Let's understand about more and more concepts in further videos. Thank you once again.